Hello, everyone. Thank you for joining Streamsets and Immuta's latest webinar, Building Better Data Management. Before we get started, I'm going to go over some housekeeping. Today's webinar is going to be recorded, and if you do not wish to be recorded, we please ask you to exit off the webinar and we will share the recording with you after. If you have any questions, please write them in the Q&A section and we will try to get to as many of them as possible. If we are unable to get to your question, we'll be sure to follow up afterwards. Thank you again for joining us today. I will now pass it off to Mike Carley from StreamSets.
Good afternoon, everybody. I'm really excited to talk to you guys today about the topic of creating better data management with StreamSets and Immuta. It's a conversation that's near and dear to my heart, and I feel like this discussion is going to comprise really two problems that I think are really the hardest problems in industry to solve today. So I'll give you a quick background about myself, about some members of the StreamSets team. I have been a solutions engineer at StreamSets for about 4 years, and it's been an absolute blast. I've had a chance to work both on the commercial and public sector customers, solving some of the really difficult, challenging problems that they've had. We also have some other members of the StreamSets team here today, notably among the public sector account team, namely Andy Force and Suzanne Puckett. They're our accounts director and business development director, respectively. I'll turn it over to Chris and the rest of the Immuta team to introduce themselves before we proceed on the StreamSets side.
Excellent. Thank you very much. Good morning, everybody. My name is Rehan Sadek, and I'm the Regional VP of Alliances here at Immuta, responsible for our public sector vertical. Also joining me is my colleague, Chris. I'll let him do his own introduction. Hey, Chris.
Thanks, Rayhan. Chris Brown, Solutions Architect with Immuta. Basically spent my career doing a lot of the data warehousing, kind of data analytic work, and really recently just came out of the SI community, building a lot of these big data systems for the government and DoD, where a lot of what we're going to be talking about today of doing good ETL work and good data governance really makes a big difference. Mike?
Cool, great, thanks guys. All right, so proceeding on the StreamSets side, I'm just gonna share my screen here real quick. Let's go ahead and share this little PowerPoint presentation I have for you guys. Chris, can you see my PowerPoint presentation okay?
It's coming through, yes.
Okay, great. All right, so I promise I'm not going to spend a ton of time doing slideware today. Really, we're just going to spend a couple of minutes to help give the audience some ground truth on StreamSets and what we mean by data operations. And then we're going to hand it off to the Immuta team to talk about access and data governance. So the StreamSets Data Ops platform is really meant to serve large analytics projects. And in order to create these complex data analytics projects, StreamSets was originally created to have a completely new take on data integration. And so when you look at major enterprises, one of the biggest problems that they have is getting the data integrated in a meaningful, robust, secure way. And so it's more of a challenging problem than you think. A lot of people want to create these data lakes to be the single source of truth, to allow a lot of innovation in a single place. And without that data lake having a constant stream of refresh data, so that way you can have a near real-time, complete record for record copy from multiple disparate systems, the data lake just really becomes a data swamp, and those data projects end up becoming a nightmare. And so people will end up using a variety of tool sets. The pretty common one that we see is they'll hire probably 10, 20, 30 contractors. Those contractors will go in and write code, and the problem is it's time consuming. It's super higher expensive to hire programmers on demand, and then more importantly, the code that they write is constantly breaking, because what will happen is they'll hard code in the exact table name or the exact column name. And then the other departments that live in those data silos, they're going out and they're still innovating. They're still trying to meet the CIO's requirements. So they're changing things and tweaking things. And downstream, you as a recipient of this data, you've already spent all this money writing these contractors to write all this code for you. Well, turns out they changed the column name, so it broke. and you're lucky if it breaks and you know about it. A lot of times stuff will break and you're probably less likely to know about it. So you'll go ahead and act on an incomplete picture. You'll act on data sets that are fundamentally corrupted or incomplete. And that is what usually ends up getting organizations and departments and ultimately decision makers in real trouble. It's like that Hemingway quote, you don't get in trouble for what you don't know. It's what you do act on that really just isn't fundamentally there, to kind of corrupt his quote. But the other problems are you have open source, which is okay. That's good for a certain smaller scale. It's never usually the complete solution, and it never lives well with the enterprise. Usually, the open source projects are about doing a proof of concept on software functionality. And so when it comes to turning that project into like an enterprise ready project, you go ahead and find out that like integrating with open source tools like into your security tools like LDAP or Active Directory or something like that, turns out that those features don't really exist. So the things doing the data integration connecting the two systems either aren't going to be fundamentally secure or require some type of waiver or sign off from the security team, which is often difficult to get. And then also there's a menagerie of tools and everybody's happy to talk to you about it, including StreamSets. But the problem is all of these tools are generally built for super specific use cases. Stuff is a lot of these tools that you'll learn about, or maybe if you do your own studying, is they're really just built for getting data into a platform. It's very rare to come across a data or a platform that's fundamentally about connecting other platforms together. That is super duper rare. So those common ways of data integration, they're okay at a certain scale, but once you start talking about doing large scale integration projects that are fundamentally required for organizations to do digital transformation, you really have a couple of key things that you have to meet. First, you have to democratize access to the data. And so that comes in a couple of different ways. That comes from the obvious story of like less technical users building pipelines and self-servicing themselves, but it also comes in less obvious ways where you have like the super smart developer stuck in a closet with his red stapler, and the guy's just a genius and he just builds the most amazing pieces of integration. Well, you have to then democratize his work. You have to find ways to share his work with a broader audience. So that's a really challenging problem. And then on top of that, the continuous delivery of data, it cannot stop, it cannot tolerate downtime. And a lot of the times the integrations that you build fundamentally are missing the operational piece that allows businesses and organizations to go forth and be confident and say, yes, this is the complete picture. Yes, we know that the integration test passed. Yes, we know that we are allowing the organizations and teams at the edge of our networks to go out and innovate, and then we'll go ahead and cope with those changes downstream. So if you don't have operational visibility into your data pipelines and you're making decisions from dashboards that those data pipelines deliver, there is a fundamental disconnect in your organization. If you're looking about IT risk and you're talking about fundamental risks to the organization, that is absolutely one of them, where if there's no testing on your data pipelines and you make decisions based on the data those pipelines deliver, I would be very worried about that. That is a very significant risk. And then the last thing is you want to ultimately avoid vendor lock-in. And so, if you guys didn't like Oracle's licensing model, just wait until AWS or any of the major cloud providers decide to stop giving you discounts. It can be a real problem. So the thing is each cloud provider has commoditized object storage products. That's relatively easy. So building a object store based data lake in a cloud somewhere, that's relatively easy. The two hardest problems are getting the data in, and then once the data is there, how do I make sure that the people who need access to it are accessing the right data pursuant to our security protocols? It's a humongous problem, and only StreamSets and Immuta can really solve those efficiently. So to give you an idea of the platforms we support, the answer is just about everything that you can probably think of. Obviously, there's going to be like some super rare stuff like, what about my high school science project from the 1980s or something like that? that's probably not going to be supported. But all the commercial enterprise stuff that you would normally see, we can generally answer yes, quite confidently that we have very deep integrations with that. And so the StreamSets platform itself is kind of broken down into two pieces. You have the ingestion function of the problem, and then you have the transformation side of the problem. So I need to bring in data from all of these data silos in a repeatable, quick, scalable, very well operationalized way. And then once the data is there, I then need to perform complex transformations in a scalable, operationalized, democratized way. Oh, and by the way, I need to perform that on those transformations do push down compute basically on any of those platforms of my choosing. And I need the whole thing to be secure. And so all the data that I'm ingesting or that I'm doing the transformation on fundamentally can't leave those platforms at the same time. Because if I don't do that, then I'm still back at the same set of problems of brittle hand coding, hire a bunch of contractors, using open source tools that don't really work. And it becomes kind of a nightmare to orchestrate all this stuff for the scale that the organizations need to operate at. And so StreamSets has basically the three components to its platform that really allow you to do those kinds of things. So at the top, you have the control layer. This is a SaaS or an on-prem offering, and it's really designed to manage and monitor smart data pipelines at a very large scale in real time. And the nice thing is the security team, they may have a security questionnaire or something like that that asks you, hey, we want a SaaS service, but the data can never leave the data plane or the data silo where it lives. Well, that's where the engines and the series of distributed engines comes into play. So StreamSets Data Collector is probably the tool we're best well known for. It does ingestion extraordinarily well. As a subset of the ingestion problem, you have data pipelines that you need to build, like streaming, change data capture from like Oracle or SQL Server. You need to do some batch jobs like batch file loading, or you need to do some light record level transformations. Like, for example, I need to check if a certain field has a social security number in or something like that. And then Transformer is our heavy duty ETL kind of engine. And so that works for either Spark or for Snowflake. If you have like a Snowflake project where you're going to use Snowpark to do a lot of your data transformation, you can do push down on that now. And that's really doing your traditional ETL workload. So maybe you have other competing solutions that may do like joins or unions or slowly changing dimensions. You can do all of that, and more importantly, those operations are highly instrumented and operationalized, but you can also push that down on a platform of your choosing. And keep in mind, these workloads can be run in on-prem or any cloud, or even a cross-cloud or multi-cloud Kubernetes cluster. It becomes very easy to do that within StreamSets. So we have a bunch of pre-built sources and destinations, so that way you guys don't have to write those destinations yourselves. You guys don't have to reinvent the wheel. More importantly, each one of these destinations or origins can be parameterized. And I'll show you what that looks like when I write to S3 in the upcoming demo. We have a bunch of transformations already made out of the box for you guys too, so that way you guys don't have to reinvent the wheel. So if you want to flatten records or put in a hash or replace values or do a lookup in the middle of your pipeline, that's all taken care of for you. Those are very well trodden paths. In order to save the developers time to make them more effective, we're not going to have them reinvent the wheel. And then more importantly, for the developer productivity aspect, we offer what's called a data preview button. And so the data preview button allows developers to step through each pipeline step by step to see what's going on inside the pipelines. And then once, as a function of those developers building their first integration inside their first sprint, basically connecting A to B, they cannot complete an integration without that pipeline being instrumented and operationalized. So what we mean by that is each pipeline and each step of the pipeline, there's operational metrics provided to you. And so those allow you to do higher level abstractions, like I'll show you in the demo in a second, whereby you can attach service level agreements to your pipelines for either data quality or data throughput, which is tremendously helpful for the business to be confident to say, yes, I know that I can trust that this data that's supplying this dashboard that I'm going to go, assign organizational resources or chart a strategic direction is fundamentally correct. And so, to give you an idea of some of the success that we found so far, in this case, in a public sector account, is maybe you've heard of Ivana inside the DoD, maybe you haven't. Basically, it's a law from Congress requiring that each government agency undergo an audit. And so the DoD for the last 20 years had a waiver, and then Congress said, no, we're not going to give you a waiver anymore. You have to go do the audit. And so you can imagine it's about 300 different master systems of record. I don't even want to know how many schemas and tables that probably includes from different ERP systems. It's probably a lot. So you can imagine if anybody changed a column name or a table name in that process, the entire audit would be cast into doubt, saying, well, your system said this system said that, what it changed on this quarter, it said that, next quarter it said this, who's right? Which is an argument you really don't want to get into when you're conducting an audit on behalf of the people that pay your bills in Congress. So StreamSets' data pipelines fundamentally did an organizational end run and really helped out the audit because it can cope with data drift. You can surface operational metrics and intelligent pipelines to the auditors. And basically every bomb, bullet, aircraft carrier, soldier's paycheck has flown through the StreamSets pipelines for downstream analysis by the auditors. What's cool is that the audit essentially paid for itself by finding stuff that the DoD has already bought. It's great that it didn't uncover any types of massive corruption or anything like that, like you might find in other militaries undergoing current struggles. But yeah, it's $2.8 trillion worth of assets spread out over about 3,000 different pipelines. It's probably more now. And basically, this is one of those things where it's a technology project that ultimately is able to pay for itself. Now, moving over to the actual software platform of what it looks like, you have a whole lot of capabilities here in the control plane. So here, what you're looking at really is is what we call Streamsets Control Hub. It's the control plane that I mentioned earlier. Now, it's a multi-tenant piece of software. So what that means is lots of organizations and lots of disparate teams within each one of those organizations can go ahead and live comfortably inside this control plane. And so what you're seeing here on this control plane is the engines and the pipelines assigned to one organization. And you can have multiple organizations. So what you're seeing is my organization. It's called SCH Carly. Nothing much to it. I got 3 data collectors, I got 2 transformers, and I got 3 data collector edges doing data pipelines at the network edge. Now, within this organization, I can have lots of users. Each user can have their own bespoke set of permissions. And so each group can also have their own bespoke set of permissions. I can monitor the overall health of the various data collectors. It becomes really easy to scale that as well. So if I want to scale using auto start groups or Kubernetes, we even have scaling agents associated with that. So basically, why that's important is I can monitor for memory usage and CPU consumption, and then I can tie that back to the individual pipeline performance. So you can imagine there might be a time when your organization buys a new ERP module, for example, and the database tables that you're reading and writing from go from 10 columns or 100 columns wide to suddenly they go from 100 to 1,000 columns wide. And so it's ultimately the same number of records, but the data set becomes that much more descriptive, and it can ultimately slow the organization down and the data integration process underneath it, so you can scale the infrastructure layer. And so this kind of capability to have a distributed, well-monitored, easily scalable underlying data infrastructure layer that can scale and respond to the needs at the pipeline level, that is fundamentally unique. There's nobody else in industry that can do something like that. Now, moving over to the left-hand side, this is where a lot of the developers live, where they build the pipelines, they set operational conditions, and then more importantly, we have this concept called a topology. So I built a topology for you guys here today, and really encompasses really just what the standard kind of data ingestion lifecycle per data silo looks like. And so the data topology that you're seeing here is really, if you think about it, it's like a supply chain. And so I'm seeing the data from the data silo, and basically there's a series of jobs that you do. The first job that you're going to do is you're going to want to do like a bulk export. Like, hey, I want to take all the data that's ever been written to there, and I want to write it out to this data lake. So most of the time, the data lake's in S3 or BigQuery or Redshift or some other kind of like object-based store. And then they're going to say, hey, once we've done this bulk export to the data lake, I then want to do, I want to have like a streaming set of changes. I want to capture all the changes to that data silo to keep that data lake current. And so you can do it on a batch basis if you want. I don't think that that's terribly efficient. I don't think that's terribly useful for the kinds of reports that you could build from a daily batch cycle versus a real-time dashboard. I feel like once things are in real time and you're actually, you and the data silo and the data lake can be in real-time parity or near real-time parity, I think that's a fundamentally different capability you're offering to the organization in terms of its decision making. And then, so once you write that set of changes out to the data lake, you're going to write a series of small files. And really, it's just a bunch of deltas, things that have changed over time. So usually the next thing that they're going to say is, hey, that's great. Thank you very much. But I want to take these small files, these small deltas, and I want to merge them in with the master. And so that's where things like the transformations come in using slowly changing dimensions. It might be a little bit too advanced for today, but really the slowly changing dimensions is just a $10 word for, I'm going to take the small changes that happened in the last 2-3 hours, merge them in with the master data set, and I'm still going to point the same dashboard at the master data set. If you've ever studied other vendors' terminology around this, bronze, silver, gold is a very common way to think about it in terms of data quality. And then, so once you've built those kinds of bronze, silver, gold tables, they're going to say, hey, thanks for building all those integrations for me. By the way, I want to orchestrate them all together. And so StreamSets can orchestrate them all together as well. So to give you an idea of what this looks like, I'm going to go ahead and kick things off with the orchestration processor. And then we'll go ahead and dive down on the individual pipeline level. So I'll kind of show you what's going on here at the orchestration level. So my first task is to grab the SCN. So most of the time it's an Oracle database. And so what I've done here is I've written just a super easy query that says, hey, Oracle, what was the last transaction you did? What was the number? What was the transaction ID for that? And then I'm going to attribute that to an expression inside the expression evaluator and say, hey, I want to take this transaction ID, I want to record it as the offset. And then say, hey, since I got the offset, I'm going to go ahead, I'm going to do the bulk load. So that's a whole other pipeline I'll show you. If the bulk load's successful, then go ahead and start the CDC job. And then, by the way, that offset that I grabbed, I'm going to pass that in as a parameter to start the CDC job on. Oh, and by the way, if things fail, go ahead and send me a Slack notification. And as far as StreamSets is concerned, this Slack integration that's here, that could just as easily be Zendesk or PagerDuty or whatever kind of tools you want to go ahead and trigger remediation. So that way the workflow says, hey, boss, I know something went wrong. I'm going to go ahead and back and check it out. So going back to the bulk export here, it's really a simple pipeline. I'm just going ahead and using all the pre-made tools that we have here. So in this particular case, I'm just saying, I want to read everything in this schema that matches the pattern of prod. And so in this particular case, I'm reading data from a COVID-19 research database, and I'm building a COVID-19 research data lake, and it's got a lot of sensitive data in there. It's got like patient IDs and conditions and health insurance information, and I don't want that getting out there. And so what I'm doing is I'm reading this out, I'm writing this out, and I want to just get a raw copy in there for people to go ahead and do queries on, because this tiny little database would just absolutely be crushed if our 20, 30 SQL developers went ahead and started writing whatever kind of queries they want to it. So these are the operational metrics. This is what we call the performance donut. This is great for developers to kind of do debugging and tuning and all this other kind of stuff. So while we're still running the bulk load, I want to show you something real quick that I'm actually taking the table name from the database and I'm parameterizing the write out. So for each table name that I read in, each table within that schema, I'm writing a corresponding directory in S3 for that bucket. So basically, as a form of the bulk export, there will be a CSV file that's created with the corresponding table name for the directory in S3. Oh, and then by the way, I'm also adding JDBC metadata and lineage information. And then I'm also creating an audit. So that way I can say, hey, all this stuff was ingested and here's the audit stream that proves it. Now, while the bulk export's going on, you'll see this kick on in just a second. There's a CDC capability here that is also producing an audit trail, but we're also reading the transactions coming out of the Oracle database. And so we're going to go ahead and add some CDC fields. And then again, we're going to go ahead and write those deltas out to a corresponding table name for the CDC operation. So I don't really need to do an insert or an upsert on those files in S3 if it's a deletion. Maybe you might require the entire history of changes, but really what we're looking for is the last operation that was completed. So it becomes really easy to actually say, hey, for this other integration operation whereby I'm going to be going and doing slowly changing dimensions, it becomes really easy to say, hey, take these changes in, go ahead, do type 2. These are the fields that I want you to work on. Oh, and by the way, I want to go ahead and port this job to do, instead of EMR, I want to go ahead and run this job on Google Dataproc, or I want to run this on Databricks, or I want to run this on Snowflake. And there's a whole host of other pre-made processors that we can provide to you as part of the functions of this operation. So this is kind of giving you an idea of what it looks like for basically the life cycle that you'll see. And more importantly, this set of pipelines can very easily be copy and pasted across the 10, 20, 30, 40, 50 different data silos that you need to go out and do integration operations on. And then once you do that, you're also going to, as part of the function of this lifecycle that you can so easily replicate across all of your data sources, you can then attach SLAs. So as I mentioned earlier, you can go ahead and attach quality of service parameters on either, the throughput or the error rate. And so what you can do is you can offer at a lower level stakeholders better granular awareness at different data at different points in the data supply chain. So if a stakeholder is only caring about COVID-19 research data, well, that's cool. You can give them very granular access to go ahead and say, yeah, Mike and Andy can read from this, but Chris, he can do it, but he can only, let's say he can only read from it. That's fine with me. So you can give lots of stakeholders very low level access as a participant in the data flow supply chain. So let's go ahead and over to S3 and we'll take a look at some of the data that was written. So here I have the COVID-19 research data. I have my deltas, I have my raw data, I have my audit trails for each one of those. And then here I can see each one of the tables has been replicated with its own series of CSV files in here. Now what I can do is I can do repartitioning of those files and write it out as Parquet to do some space savings. There's a whole host of other use cases that we can kind of get into, but this is really the fundamental life cycle that you kind of see per data source. And replicating that per data source is often a very time and developer intensive focus. So with that being said, I'll kind of go ahead and hand it over to Chris to pick it up from here. Now that I've written out my data successfully, Chris will go ahead and apply data governance policies over this data now that it's been successfully landed into the data lake.
Perfect. Thank you so much. So first and foremost, I am not Chris. We're just going to run through a few quick slides about Immuta just to kind of give everybody an understanding of what happens as the next phase of the overall process. So what was shown prior was basically how you could more or less pick up data, extract key parameters from it, and place it into a variety of sources. In this case, we chose just S3. But once the data is there, what needs to happen is you need to basically tie and give your end users access to that data while at the same time being aware of any sensitive information. And that's exactly where Immuta comes in. So first and foremost, welcome to Immuta. We're the automated data access and privacy control company. A little bit of background about Immuta. We actually came out of a public sector use case driven by the intelligence community. All of our founders were former military and former intelligence analysts, really working some very interesting and complex problems within the IC around not only sensitive data access and discovery, but also how to share that sensitive data. And they literally got together, formed the best possible solution for it. And since then, it's been absolutely amazing growth. And we have a large variety of trusted names and trusted brands across the world that have standardized on Immuta to basically help them meet that goal. Now, Immuta's mission is actually very simple. We help the world enforce data policies everywhere. But with that simple mission, we've been involved in some very complex use cases. So for example, customers such as Ginkgo Bioworks have basically leveraged Immuta to help open up 40 additional COVID testing labs across the US. Disney Plus leverages us to take a look at sensitive user data to determine which markets they should grow into next. And then within the financial services arena, we've been employed in a variety of use cases. One of the more interesting ones is how we've helped organizations like Swedbank basically increase the accuracy of their fraud, waste, and abuse efforts. So within the public sector, we've got a strong array of committed and growing customers. As was pointed out prior, we are also part of the Advana platform. We're also leveraged in several shared data environments, such as the U.S. Air Force Vault program, as well as a variety of programs in both a civilian and the DoD sectors. Before I kind of get into exactly what it is that Immuta does, I do want to highlight what the problem is. And you may or may not be aware of this, but data policies can absolutely be a roadblock to secure scaling. And let me kind of illustrate what that means. So in the beginning, you have data sources and you have data users. And you basically tie your data users and grant them access to your data sources through the use of what's known as data access and control policies. What happens though is that as you add the number of data sources and as you add additional data users, the number of policies that you have to create, govern, and manage doesn't just increase linearly. It can actually increase in squares, so it can grow exponentially. And just to better illustrate what that problem looks like, this is actually taken from one of our current customers who had just 100 data platforms. They had 20 regulatory frameworks that they had to basically comply with. They had to do that across 5 geographies and basically meet 2 mission-specific needs. What they found is that they would have had to create, govern, and manage over 500,000 policies. That in itself is just a completely unmanageable problem, and that's exactly where Immuta comes in. Now, Immuta does that in a variety of ways to help basically scale that overall solution. But we fundamentally do it by allowing you to separate the policy from the platform. And what I mean by that is that we allow somebody to basically create a policy and have that go against a variety of data sources, compute, and storage environments. And we also make that experience seamless to the end user. So regardless of the type of user that you are, such as you might be a data user that basically is somewhat akin to like a data analyst, You could be a data engineering user who basically, has a pretty deep technical and computational background. You can continue to use the tools, the environments, and the frameworks that you're currently using. Really, the only users that are ever aware of Immuta are the data owners who, have to basically answer 3 fundamental questions, such as who has access to my data, what are they doing with it, and am I in compliance? Or folks that are in some sort of an audit role who often have an analyst skill set and thereby can leverage Immuta's purpose-built application to create, govern, and manage policies. In addition to that, Immuta can help you accelerate secure data access. We do it by fundamentally being very easy. So we plug in to the data infrastructure. We don't act like a proxy. We don't mandate that you basically route all requests through us, etc. We make it so that it's compliant. As I pointed out prior, somebody with an analyst skill set can author, create, govern, and manage these data access policies. And fundamentally, we help you understand exactly how your data is being used, and so therefore we can monitor and report against every action. Just to kind of illustrate what that looks like, and Chris is going to kind of show you this in the actual demonstration as well. In a world without Immuta, you're going to write an awful lot of custom code. A lot of times there could be performance issues, specifically if a proxy-based approach is more or less being used. A lot of times people try to get around these problems and they create copies of data sets everywhere. And then you fundamentally have to do various disparate audit functions just to kind of organize and understand the data that's basically out there. And in a world with Immuta, this is an example of our purpose-built interface below. As you can see, somebody with an analyst skill set can get a guided experience in terms of creating, managing, and governing data access and control policies. So leveraging an application like ours that is purpose-built, they can create the exact code that's needed to be infused into their various storage and compute environments. Much like StreamSets, Immuta plays well with others. You can kind of think of us almost like an agility layer, because we are leveraging other infrastructure components such as identity and access management controls, external metadata or data catalogs, as well as various audit applications. And Immuta is basically that layer that allows you to natively plug in while at the same time making that experience seamless to most end users. With that said, I'm going to stop sharing right now, and I'm going to turn it over to Chris to kind of take you through look at our tech.
Great, thanks, Rehan. I'll take everyone through a quick demo of Immuta here to give you a sense for what we can do. So I've already logged into Immuta as an admin user. I want to show kind of how we utilize user attributes to be able to set some of these roles along with the data attributes. So Immuta integrates with any identity management system that's conformant to any open standard, LDAP, SAML, OpenID Connect. Within this demo, don't worry about permissions. That's really just for Immuta in this case. But we're going to focus in on are these attributes and groups. The groups are our traditional roles and groups that we've built policies on before. But where Immuta starts to kind of separate out a little bit is around the attributes. So you can see this user has a lot of different attributes associated with him. We're going to focus in on this yearly training, right? So within the public sector, contractors and government personnel have to take a number of different trainings every year, and a number of them are Privacy Act of '74, HIPAA, and cyber awareness. So what we'll see in this demo is that a user with all three will be able to see all the data, and my other user will not because he's missing the HIPAA compliance. Changing gears as someone who is more of a chief data officer or data steward, one of the key things people want to be able to do is be able to automate data use agreements, or what we call purposes. So within Immuta, you're able to create these purposes. You can see I have things around ethical AI development. I have interagency, intra-agency type of agreements. And what we'll focus in on here is within the medical community, the safe harbor agreement, which basically says that you're not going to re-identify anyone within the cohort that you're studying. For data attributes, Immuta does provide a lightweight data catalog. We also integrate with all the industry leaders such as Calibra and Elation. So you can see I can make some tags like I've done with the data domain here. Everyone's pretty hot on data mesh these days. But what is important here that I'm going to show you is that out of the box, Immuta does sensitive data discovery. We identify over 60 types of sensitive data, which I'm showing you here with these entities. So you see things like bank accounts and credit card numbers, date of birth. And if I come all the way down to the bottom, you'll be able to see things such as passport number, social security number. And what's unique about Immuta is that we also allow you to create new sensitive discovery rules. So now with some of those user attributes and data attributes, what we're able to do is develop policies. We have two types of policies. What you're seeing here are data policies, which are the fine-grained policies. But you also have subscription policies, which is how you gain access into an actual data source. These rules for subscription policies, and you'll see with data policies, are very easy to create because it all utilizes drop-down menus. So all of the policies have a name. You're able to set your rules, and then they say how they get applied. You can create templates for data owners to apply the rules themselves. You can make it as this one is across every data source within the system, or as we'll see on the data policy, I segregate out the data of how it's going to be applied. So for a subscription, gaining access into the data source, Immuta provides a number of different ways to enable this. You can make it public. You can make it private until a data owner adds individual users or groups. You can allow for automatic subscription based on what group or role or combination of those that you have. Or in this case, anyone who asks to be approved and is approved by an actual owner can gain access. Why is that? Sorry, not sure why my policy, there we go. Stuck there for a second. So looking at the fine-grained access, just because you have access into the data source doesn't mean you have access into all the data. So we'll look at this medical data, right? So Mike talked about the COVID data set that we're looking at. So we're going to look at that data set a little bit further here. So obviously that's the medical data set. And as you see here, like all the rules written within Immuta are plain English. I think anyone on this webinar can actually read each of those rules and understand exactly what's going to happen. So within here, you can see that we have our name. We can see that I've applied it to anything within that medical domain, that tag that I created earlier, and then the set of rules that we have. So in this demo, you'll see a lot of masking capability, but also Immuta is able to do row filtering based on user attributes and dynamically at runtime interject those attributes to match up into certain rows and only bring back those rows. You're able to do the same things like dates and times. So like show someone only data older than a year. We'll see limiting to that data use agreement or purpose. You can show a smaller set of data, so like only 75% of the data. And then we have 3 privacy enhancing technologies. One of them here, differential privacy, but also k-anonymization and randomized response. What's great about these is that they don't destroy the data like a hash or a mask type of thing does. It adds a little bit of noise into the data set, which doesn't enable someone to re-identify someone, but also doesn't destroy the data. And so you can still use the data for analytical purposes, and they've been shown to not change your analytic. There are a number of different ways I can apply these rules. You can see a number here. In this case, how things are tagged. I'm using a couple different tags, and they can be and or together. To mask data, there are a lot of different ways, such as constant, hashing, making it null, regex expressing, rounding dates and times, and things of that nature. But then we also have these two things with reversibility and format preserving masking. So with reversibility looks like a hash. Format preserving looks like a social security number or a credit card number. But what they do is they allow the person who's seeing the masked data to ask to see the real data. So think of a fraud use case to where I need to see the real credit card number to go further my investigation. And then you say how this rule gets applied. So it can be applied to anyone except what you see here, but based on exception, or anyone who meets the criteria. So this is by exception. So you can see I have to have all my yearly training and be part of the researcher group to be able to gain access into the data. So what does this look like from a data source perspective? So within Immuta, again, we have that lightweight data catalog. You can see this is actually integrated into a number of different data sources. So what's great about Immuta is that kind of like as an old Java developer with their promise of write once and run everywhere, within Immuta, you create a policy once and it gets implemented across all these different technologies that I'm integrated with, for example. We also allow you to do searches. So you can see I pull up data sources, columns, tags, and even global policies here. But we're going to look at the patient's data set. You can see I'm able to see a lot of information about the data set, how it's been tagged, but also I can look at the data dictionary. So as we integrate into these data sources, Immuta, again, fingerprints these data sources. We do not ingest any data from them, but we need to bring back things like column names, their types, and even descriptions. Within Immuta, you can add tags, you can remove tags. If you need to edit information about like the description, you're able to edit that information here. What you see is that we have run our sensitive data discovery. So we've discovered things like driver's license number, passport, social security number, and even things like people's first names and last names. Finally, with those generic policies that I created, what do they look like when they've actually been applied to the tables? So you can see here, based on the rules that we've set, the rules have been applied to each of the different columns within this table, and you can see exactly what's going to happen within each one of those. Immuta allows data owners to create additional policies by adding a new policy, and you can see I created a new local policy here for limiting the data to that data use agreement. So now what I'm going to do is I'm going to go into Databricks. So what I've done is I've taken that patient's data and that COVID data set, and this is one of the tables we can look at, and I brought it into Databricks into a table. So now I'm able to go in, and as a user who you'll see is able to see all the data, I'm able to run through kind of a use case. So I'm going to show you the list of these projects here, because I'm going to need this ID a little bit later, and I want you to see where it comes from. And projects are where data, purposes, and users all come together. So to enforce these data use agreements, you can see that I can unset my project, which means I'm not working underneath a project. I'm going to go into that data set that we just looked at, and you see I get an error. That is because I don't have the correct project set within here. I'm not working underneath that data use agreement that I'm supposed to. And what's great about Immuta is that all these actions are audited. So you know when people are actually accessing the data underneath, in this case, safe harbor purpose, that they're actually really working underneath that and that they are trying to do it. So now this is a user who can see all the data because he has all those caveats. Now I keep this user here so you can see what the data looks like, kind of free and in the clear. So you can see, social security numbers, passports and driver's license numbers, names are in the open, and then things like the lat long and the address are in the clear. So I'll quickly move to a user who cannot see all the data. So he'll run through the same kind of thing, right? So you'll see he unsets his project. He then tries to run command on the patient's data with COVID. Again, gets that incorrect project. We now go into our safe harbor project. Now this user is missing his HIPAA compliance. So with that missing HIPAA compliance, what you'll see is that data is now masked out. So we've done a regex on social security number. We've hashed out the driver's license and passports. We obviously talked a lot about the name and redacting those names there. And then you'll see things like the lat long and the address have been completely nulled out for this user, and he can no longer see that type of information. So that's a quick run through of how Immuta picks up where StreamSets left off, which is basically hydrating our data lake, where we can then bring that data into the data lake and set some data access rules on top of it to make sure that the right people get access to the right data. So with that, I'll stop sharing and I will hand it back over to Mike.
Thanks. I guess now's a good time to check in for questions from the audience. Mary, do we have any questions?
Yes, we have got a couple questions in, and it looks like we're almost to the top of the hour, so we probably have time for about 2. So if we do not get to your question, we'll be sure to follow up afterwards. But the first one is an Immuta question. So Chris or Rehan, let me know which one you want to answer. But what networks has Immuta received an ATO?
Yeah, so because it's public sector focus, that's a good question. So Immuta has been ATO'd on unclassified NIPRNet, CIPRNet, and JWICs within the DoD and Intel environments. We're also residing on at CBP within their unclassified environment, and we're actually looking to get our first ATOs within our health customers within the government, such as DHA.
Perfect, thank you. Mike, this might be a question for you. What existing customers do you think represent the pinnacle of data ops maturity?
That's a good question. You can probably take a look at like some of the big guys like Airbnb or Netflix or something like that. Those guys have pretty well documented um, practices, but the problem is they hire a bunch of like super expensive data engineers. Like to give you an idea, like a senior data engineer at Airbnb, it's not uncommon for them to be making 450 or almost $500,000 every year. And some organizations just can't afford that kind of headcount. Within StreamSets, though, practicing data ops, I think GlaxoSmithKline is probably one of our reference customers on that front. They have like a 5 or 6 man team of Python developers, and they use the StreamSets SDK to scale the creation of their data pipelines. So that 6 man team writes programs that run about 1 to 2 million data integration pipelines dynamically every day. So I think that represents probably the peak that I've seen for data ops, and they do all the testing as well to support that. So they have a whole CI/CD process.
Perfect. Thank you, Mike. Well, thank you all for joining us today, and thank you to all of our presenters. We all hope you had a great time.
Thanks, Mary. Thanks, guys.